Um, so, okay. When's the last time you were interrogated while leaving a country? Turns out most authorities are concerned about Turns out that most authorities are more concerned with things entering rather than things leaving. I think this metaphor illustrates properly how developers handle service traffic. A lot of time is spent on making sure that ingress is handled properly, and egress is often neglected. So this talk is about best practices regarding handling egress traffic. All right. So hi, my name is Marc. I come from Montreal. So right now I work at Stripe as a security engineer. Before that, I used to work at Samsung, and during that time, I graduated from Université du Québec à Montréal. Yay! All right. So, all right. Since we're going to be talking about egress, let's define what egress is. In order to be egress, there has to be your organization. Your org is going to be defined as the set of services that your company operates. I'm sure it's neat and tidy, but in order to either provide services or consume services, your organization has to be part of something way more scarier, the World Wide Web. So now we have all the, so in the World Wide Web lives providers, clients, as well as threats. Now we have all the pieces to describe egress. Egress is simply a data transfer or a session which is initiated from the inside of your organization to the outside. All right, so let's get more concrete with it. This is your org, your services. Common use case for egresses, for egress. Let's go with webhooks. Webhooks are super popular in order to inform your customers whenever an event happens. For example, at Stripe, you can go in the dashboard. You can provide, if you're a merchant, you can provide us with a URL and select which event you're interested in. And whenever it happens, we're going to send you a notification. So this is obviously going to be a session that originates from the inside of our organization that's going to go outside to the merchant's organization. Another case is polling. Polling is when a service wants to go fetch a resource in order to use it. Another Stripe example would be receipt teaming. If you opt into this feature, we will send a receipt to your customers whenever there's a successful charge. But in order to team the receipt to your company's color, we will go and fetch your website, extract the color scheme, and then team the receipt with that. No, the presentation is not broken. This is a polling case from Google Docs. So you can insert an image in a document by providing a URL. This means that Google is going to go and reach out for the image on your behalf and insert it in the document that you're making. The last case, and maybe the most common, is third-party services. So whenever you want to consume a service, for example, whenever you want to send a text message using a platform like Twilio, you want to send an email, or you want to reach out to a cloud provider in order to spawn new instances, you will have to go and reach out for those service providers. Something which is somewhat common with service providers is that they provide libraries in order to interact with them. So you're not making the request somewhat manually. You'll use the interface they provide, which makes your life simpler. All right. So now that we know about some egress use cases, we can try to categorize them in two big families. So there's restricted and unrestricted. Restricted works super well for service providers. It's for use cases where your addresses or addresses or names are not going to change often, and you can identify them by identify them by functionalities that are hard dependencies. Basically, your service won't work without those external resources. The unrestricted case is ideal for things like webhooks, when it's your customer that's going to provide you with a URL to go and reach out for. This is for the use cases where you can go. This is for use cases where an address or a name can change. For example, I can just go on my dashboard, change a webhook destination, and it's all going to be fine. You can usually those don't have your service doesn't have any dependency on those. If those resources are not available, your service is not going to be degraded. All right, so let's try to do some naive egress. So this is again your organization, and this is the public web. In your organization, there are services. For example, there's an API, there's a database, and there's a message broker. If you want to reach out to example.com, in order to make this example more lifelike, let's give those services IP addresses. So if API service wants to reach out to example.com, first it's going to have to go and reach its IP. It's going to use a public name system and retrieve an IP, and then it can connect to the service. There are a couple issues that come with that, doing it this way. The first one would be SSRF, so server-side request forgery. This is an abuse in functionality where you make an application, make a request to somewhere where it was not where it's not intended. So for example, if I go back to the dashboard and in the webhook URL I set localhost, the API service is going to resolve itself. So this is pretty bad because you're going to have some interaction with something that the service is not expecting. So on the same host, there could be another service listening on another port, and if you say localhost and you just try to enumerate ports, you might hit something that you're not supposed to. If you try to resolve for 10.0.2.xip.io, everything, and if you put an IP address before xip.io, that's going to resolve to the IP address you put in front. So in this case, if in the webhook text box I put this one, I'm going to go and hit the database. If I try to resolve this one, ono.tremblay.io, I'm going to resolve 10.0.0.4. And then what about example.com? In the previous slide, we went and reached out for it. Nothing guarantees, there's no guarantee that example.com will still resolve to something public. Maybe the name system has been compromised. Maybe the owner of the domain is a rogue actor, so no guarantees there. What about 169.254, 169.254? This one is a linked local address. For example, if you run on AWS, this is the metadata endpoint. Your instance will go and reach out for user data or credentials that it's going to use to interact with other AWS services. So if I provide that in the webhook URL, and if I can view the result of like going fetching this data, I will be able to get AWS keys for this instance. All right. So what's the solution? How can we fix that? We just have to make sure that the IPs, so whenever we resolve an name or whenever we get an address, we have to make sure that this address is actually going out to, is actually pointing to the public internet. All right. All right. So how do we define what the public internet is? It's actually easier to define what the private internet is. The most up-to-date RFC on that is RFC 6890. It's going to give you a list of special special CIDR blocks that are meant to be used for private usage or like special test usage. So basically, you just have to ensure that you're not trying to connect to one of to an IP. When you're trying to connect to some remote host, it's not at one of those at one of the addresses covered by one of those blocks. All right, so if you want, this talk is not about SSRF. So if you want to know more about that, it's a well-known class of attack. I highly suggest Orange slides. They have pretty good slides. All right, another issue that can arise is unsolicited egress. So again, there's your org, there's the public web. If a host gets compromised, it has access to a database, it has access to other services such as the message broker. There's nothing that would permit your host from exfiltrating data. So the solution for that, of course, you just give the smallest set of permission to each service. So for example, if your API service does not need to access all collections in the database, just give it a small set of, just give it the least set of like collections it can access. Just try to restrict the permissions. Same for all internal services. If your service does not need to reach out to undetermined addresses or hosts, only allow your service to talk to the host you want to allow it to. Anyways, sorry, let me rephrase that. Only allow your service to talk to remote hosts it's supposed to talk to. One last thing, DNS data exfil, it's been seen in like 2 talks earlier. So for example, let's say we own the name server for evil.com and we try to resolve secret.evil.com. The name server is going to be aware of what secret was. So as long as you have access to the public name system, as long as your service can access the public name system, you're still somewhat vulnerable. You're still vulnerable to that. So what's the solution for that? Well, don't let your service talk to the public name system. So now we put many restrictions on like things we should or shouldn't. We just like said things that we should or should not do. For example, this one, which is like, hey, don't resolve public names. So there's only one question that can come up. What are we gonna do? All right, so we can look at existing things. So for example, there's IP tables. It's great. It talks in terms of addresses, but it doesn't know anything about names. And if you try to restrict some, like a host from talking to some, if you try to restrict a host from talking to some other remote host to some addresses, you might just not be able to talk to some internal services, which might not be what you want. DNS mask is great, but it does not know about addresses. And so if you want to do something with both, it would be like somewhat hard. You'd have to find a way to synchronize. Actually, like I don't want to think about that. You could use a proxy to proxy all the requests that go to the outside. But if you use a simple proxy, there's nothing that will prevent a proxy from resolving things that are not accessible from the outside, if the proxy obviously has access to those. So what we need is, do you remember the good old phone operator? I don't. I'm too young for that. But they are what we need. We need to bring them back. So let's think of domain names as people names, and let's think as domain. Let's think domain names are people's name, and IP addresses are phone numbers. So we need a phone operator that's going to ensure that whenever I'm using this phone to call another person that's outside my company, whenever I make this call, this operator will actually figure out that, oh, I'm actually trying to call outside, it's great. I'm trying to call inside the company, it's bad. Also, if this operator needs to know who I am, if I'm only allowed to call person ABC, if I try to call person D, it won't even go and look up its phone number. It will just say, no, sorry, you can't do it. On top of that, we want an operator that when they see something wrong happening, they will just tell the police so they can go and fix the problem. Yeah, that's the security team, basically. All right. So our solution for that is Smokescreen. It's an open source project. It's totally free. You can contribute to it if you want. So it's a HTTP an HTTP connect proxy. So basically, I'm going to expand on all those points in a few minutes. It has a notion of client identity. So if it knows which service is trying to reach outside, it performs the name lookups with the public name service. It also performs request authorization. So you give it an ACL that says, oh, this service is allowed to talk to this remote host, and it will basically, it's an allow list. It collects some metadata about the connections that are established. And on top of that, it does not decrypt proxy data. All right, so let's go. Who's familiar with HTTP proxies? Yay. All right, so HTTP proxies are somewhat simple. The internal service will make a request to the proxy. This request will be sent to the remote host. The remote host will respond to the proxy, and the proxy will respond to the source service. This is really simple. There's one downside to it. It's that the proxy has to be able to read the data from this HTTP session to be able to figure out where to connect to. So it won't work with encrypted, so basically HTTPS. Yeah, sorry, I forgot to put the next slide. Okay, so now it's HTTP Connect proxy. The way this one works is a bit different. You will send to the proxy the verb connect. You will tell where you want it to connect, as well as the port. And then you can send headers to the proxy. All right. And then once this is so basically this is data that if you want to identify to the proxy, you could send, let's say, a cryptographic proof that says like, hey, yes, I'm this. This is a proof I'm this service. So it could be a great way to identify your service to the proxy. And then once the headers are done, the proxy will go and try to establish a connection. If the connection establishes properly, it will go and tell the local service, hey, it's fine, use this connection as a tunnel for talking to outside, to where you actually requested to talk. All right, so it also performs request authorization. So you can provide it with an ACL. We're going to see one during the demo. You can provide it with an ACL and put rules into either enforce or report mode. And for a little bit like SC Linux, if a rule is in enforce mode, anything which breaks the ACL is not going to be allowed. And if you put it in report mode, you're still going to get flags if things are not in the ACL, but it's great in order to test out policies. So basically, let's say you're not using anything like Smokescreen at your company right now. You could start using Smokescreen in report mode, start collecting data, and once you feel comfortable, you can, and now you can build an ACL with that data that you collected, and once you feel comfortable, turn that in enforce mode, and and now you're a bit more secure. All right, so we're going to look at an ACL. Warning, there's some YAML, so I hope you brought your rulers. All right, so you have a list of services, and you have a default rule. So name is the name of a name of a service. Project is the name of the team that's responsible for that service. So if you want to be able to tell, oh yeah, this project is owned by this team, and you want to give them alerts, then it's a fine way to do it. Also, you can provide a list of allowed domains or addresses. So for example, this would mean that my meme service would be allowed to only reach out to example.com and everything that is like every subdomain from example.com. So it's pretty simple. So Smokescreen has a notion of client identity. One thing I didn't tell you is that Smokescreen can be used either as a binary or as a library. If you use it as a binary, it will provide you with SSRF protection. Basically, everything that you try to proxy to it will just ensure that you're not trying to connect to a host that is in a local, in a special IP range. But if you use it as a library, in the configuration item that we're going to see in the demo, you can provide it with a function that takes a request and that returns a service name. So basically, once you return the service name, Smokescreen just runs with that and assumes that the connection was established by that service. Performs name lookups. So whenever it receives the proxy request, it will be able to extract what is the remote host and handle that properly. So there's no URL, it limits URL parser abuse. So URL parser abuse are when a URL which has been forged will be interpreted differently by different parsers. So you could be in your application logic taking a URL, making sure, oh yeah, it's this hostname in it, and you pass it to, let's say you pass it to another step, and the step passes it to curl. Curl is going to parse it, but might parse it differently, and in the end, you will not be reaching out to the host you were expecting because of this parser abuse. Also, one thing which is nice is there's one IDNA rule set across the stack. So IDNA is the internationalized domain names in applications. So for example, it's for URLs that contain characters that are not ASCII. So anything which is Unicode, we need to have a way to translate it to ASCII-only URLs. So since we're handling names at this step, we know that all the names across our stack are going to be handled with the same rule, which is great. Because now in the ACL, we can just write this final ASCII-only domain name. Also, it won't resolve a name it should not. Because of the step we saw previously, this is actually what prevents DNS data exfils. If it knows that a host should not be reaching out to, if it's trying to reach to a domain it should not, then of course it's not going to try to go and get the address for this host. All right, so one last thing. it does not decrypt proxy data. This is super important. It's important because if a proxy box gets compromised, then the attackers don't get all the traffic. Yeah, so there can still be a TLS session from the source service to the remote host, and the proxy won't be able to eavesdrop on it. So yeah, yeah. So where does Smokescreen fit in infrastructure? So you have your services that can talk to the internet in any ways. There's a layer of there's a layer of Smokescreen servers or proxy boxes, and then there's the internet. So the only way is to go through Smokescreen. The only way to reach the internet is to go through Smokescreen. So let's see how we would reach out to the internet using Smokescreen. So here's your service. It's going to connect to Smokescreen, and then it's going to say, hey, please let me reach out to example.com. I'm service X. Ideally, provide a cryptographic proof. Otherwise, like if I just provide a string saying, oh yeah, that's my service name, then any service could impersonate any other service, so that would be pretty bad. So a good way to do it would be to talk with Smokescreen in mutual TLS. That's actually what we do. Or if you'd like to, as I said earlier, use a JWT, that would be fine as long as you set expiration and have a way to revoke them. So once this is done, Smokescreen will use a function that you did provide that will extract the service name from the request. Once it's done, it will check with the ACL. Hey, is this actually a good thing? If it is, great. It's gonna continue. If it's not, then it's just gonna tell the requesting service, sorry, I can't do that. So once this is okay, it's gonna do the name, the address resolution. Yeah, basically. And then from the resolution, it will get an address, and it will just check if the address belongs in one of the CIDR blocks that we saw earlier. If it does, then it's going to say, tell the service, sorry, can't do. If it's not in those blocks, then it will move on. It will try to establish a connection with the remote service. If this is successful, it will tell the service, sure, go ahead. Use the connection that we established earlier, and use it to talk to the remote service. So basically, the connection downgrades. Yeah, so it's time for the demo. Right. This is where everything is supposed to go bad. All right. Oof. All right. So in order to use Smokescreen as a simple SSRF protection, you can just clone Smokescreen, build it. So here it's, can you actually see, it's a bit small. All right, I'll just go in every window and just that's better? Okay, so you can just build it and then start using it. Smokescreen speaks statsd. So whenever so this is the way we collect metrics. It's pretty great. So whenever there's a name resolution which is successful, or whether the ACL is whether a connection is being denied, we will just increase a counter, and we will be alerted based on that. So I just started Smokescreen locally. Oh, I'm just gonna and I'm also gonna listen locally on UDP 8125. And all right, what else? So I'm just going to try to use Cura and try to reach out to google.com. So basically here, -x means I'm going to use a proxy, which is located there, and this is where I want to reach out. Don't mind the header for the moment. So let's look at that. It was successful. Here we got a response from Google. So you see at the top there's a connect, and then the destination and the port. This is what was sent to the proxy. The proxy got that, and then the proxy established the connection with Google, and then and then once the connection was established, curl could talk directly to the server that the remote host. So this is great, but now we're talking about SSRF. So this resolves to 10.0.0.4 as we saw earlier. Yeah, so Smokescreen just said destination address is 10.0.0.4, so it's a private range. Sorry, we can't do that. Anybody has an address that they would like to try for fun? No? All right, I'll just like do locals then. Yeah, so it was denied. Yeah, it's not a global unicast. Sorry, it's not gonna work. So this is great. So this is like, this is Smokescreen as a simple proxy. But now we will quickly extend Smokescreen. So in order to use Smokescreen as a library, it's super simple. You just have to basically import the proper packages, build a new, create a new configuration, and then pass it the function that you want to use for this request to service name. So here, we're just going to extract the header X application role, and if there's a value for it, return the first one that we see. If there's and if there's nothing, just return an empty string. Empty string is considered as the default service. And here's our ACL that we're going to use. So basically, we're going to have a project we're going to have a service called memes. Memes can only reach out to Imager because that makes sense. There's going to be another service called Webhooks, which can talk to everything. And the default rule for other unidentified services is going to be enforced with no list of hosts. So basically, can't talk to anything. So let's go and start this one. So basically, oh yeah, I forgot to show you, where's the UDP thing? Oh yeah, so basically this is statsd. Oh my god, it's so small here. Oh, oops. Oh. Yeah. All right, so basically, those events are basically in the statsd format, and they were triggered whenever we try to reach out to hosts. So for example, here, I'm just trying to attempt. So basically here we see we had a deny private range, we had and a deny not global. So this is great because if you want to set alerting on that, you can just do that. All right, but the ACL you get more information. So all right, where is it? All right, so let's start this Smokescreen, which was used as a library with this function to extract the service name from the header. Don't do that. It's not safe. Don't do that. Use some, as I mentioned earlier, use something that provides a cryptographic proof that, something that you can't tamper with. All right, so now it's there. It's listening. Now we're saying that we're, oh, sorry, that's not working. So let's try to make the same request to a legitimate host. So let's try to reach out for Google as the service name memes. As we saw earlier in the ACL, service memes can only talk to Imager. So let's, what does, all right. Yeah, so basically we got this. Role is not allowed to access this host, which makes total sense. And now if we try to reach out to, yeah, this did work. The network is slow, so yeah. But now we got the response from Imager. So basically, it's a neat way of, it's an allow list. It's a neat way to restrict what services can talk to. All right, let's go back to the slides. Sorry about that. Really? Okay, great. So to conclude, Smokescreen is our answer to both SSRF and data exfils. It's not perfect, but it can definitely reduce the blast radius of a compromise. Yeah, also one point, which is one other side effect of using Smokescreen is since there's only one tier of Smokescreen hosts, we can provide stable IPs for our partners. If they want to ensure that, hey, we're going to receive webhooks from Stripe and they want to make sure that it's from a certain IP, that we can provide them with IP ranges. Yep. So I want to say special thanks to Ryan, one of my coworkers that also worked pretty heavily on Smokescreen, and the team for all the input. I want to say thanks to Christina for lending me your tablet so I could draw those slides. Rachel for the mentoring, as well as other Smokescreen contributors. So this is a QR for the slides if you're ever interested in them. I would like to have your feedback on this presentation and as well on Smokescreen. If you think that Smokescreen is applicable in your organization, we'd like to know. And also, oh yeah, also forgot to say thank you, Stripe, for shipping me here. That is great. I appreciate that. Yeah, anybody has questions?
Why is that Prometheus?
Oh, that's just the way we do things. I guess that what you could do is have a local sidecar for aggregation and then just present a Prometheus endpoint. So it's not a big deal. I think that's totally workable. So.
Is it possible to deploy the service in a global or being highly available?
Yes, actually, the way we use it internally is in a highly available way. One host will have multiple Smokescreen instances, and whenever we want to roll out, let's say, a new ACL, we make sure that we drain the connections from every of those hosts, and they get replaced with the new ones, with the new version or the new configuration. So yeah, it has to be deployed in a highly available manner, otherwise you're going to have service interruption.
You mentioned that if you want to authenticate services, from what I understand, you basically have to use Smokescreen as a lib, which in my head implies I kind of have to roll my own authentication here. Is there like a built-in saying will work, will not screw me over?
No, you have to extend it and provide it with a function. But it should be somewhat simple. Like internally, the way we use it is like 8 lines or something. Basically, since every machine has a machine has a client cert, from the request you can access the TLS context for the session, and we look at the client cert. So, I mean, of course you have to implement it yourself, but it's not like it's 8 lines of code, and you can get it reviewed by peers, and that should be sufficient. Yes, I think. Does that answer the question? Yeah, thank you. Any other question? Yay, we're done. Thank you so much.